Okay, lesson 1.4, day 2. So yesterday, we looked at combination functions, so just the basics, how we add, subtract, multiply, divide, pretty basic, right? Then we looked a little bit at composition of functions, which is what I refer to as the Fogg and Goff type stuff. And now today, we're going to continue looking at compositions, important data here, and we're going to start talking about domain. Okay, so talk a little bit about domain today. So, in order to talk domain, we need to kind of know what we're finding domain of, right? So, first thing we're going to need to do is we're going to actually need to find the composition. So, in this third example here, we are given a new f and a new g. Pay attention to when they give you f and g or whatever in your directions. They want us to find the domains of Fogg and Goff, which means we need to start off by finding Fogg. So f composed with g of x. Okay, help me out. F composed with g of x. What does that mean? We're putting what into what?
Nobody?
Okay, but just, we're not getting detailed here, right? If it's Fogg, I always rewrite it as f of g of x, which means what's on the inside? G. And g, so that means g is on the inside, so it's going to be put into f, which is on the outside. So we're going to take g and put it into f. Now, with that in mind, okay, what is g? Square root of x. We're going to take that square root of x and put it into f. What does f tell me to do to x? It tells me to square it. So what is it that I'm putting in place of x there? Now, the whole function, which is square root of x. So we're going to take that square root of x and we're going to square it. So I'm going to write this as the square root of x squared. And then what else do we have to still do? Minus 1. So that's the idea of Fogg. Huh? Okay. I just say give it a chance. Because I know I didn't get this last year. Each year it should you should get a little more understanding of it. Okay? So that's, keep working with me. Don't just tune out and say, I can't do it. Yes, you can. Baby steps here, okay? Now, officially, we could simplify this, couldn't we? What happens when you square the square root of x? When you square square root, you get x, whatever's under the radical, right? Because the square and the square root are going to cancel each other out. Now, for the purposes of the fact we're going to talk about domain, I'm going to leave it like this. Like if I was simplifying, giving a final answer of what's Fogg, I would say Fogg is x minus 1. But we need to talk about domain. And so when I talk about domain, what does domain mean? Domain is our, what type of values? X or Y? X, right? So domain are the X values. So here's the question. As you look at this, what kind of X values am I allowed to use? What type of X values are we allowed to put in there? So in this case, it's what type of X values are you allowed to have under a square root? That's what I'm really asking. Positive? Can X be negative in this particular problem? No, because it's a square root. So X has to be positive. Can we include 0? Can you take the square root of 0? Yes. So that means what type of numbers? We're going to talk about numbers that are greater than or equal to 0. And this is why I didn't just make it x minus 1. Because if it says x minus 1, I can take any number I want and subtract 1 from it. So this is why I said I I left it as square root of x because we need to be able to see where it came from. So x is going to have to be greater than or equal to 0. How do we write that in interval notation? And if you're thinking, oh, crud, this is where I lose it, well, okay, think. What does this look like on a number line? Greater than or equal to 0 is from 0 going to the right, yes. What's at 0 if it's greater than or equal to? A bracket. So that's what's in your brain if you need that. What is that in interval notation? I agree. Bracket, 0, comma, infinity, parenthesis. Because it's saying 0 to positive infinity, and 0 is included.
So if we just graph that on our calculator, like the square root of x squared minus 1, will that give us a graph where it starts from 0?
No. It would give you the graph for x minus 1.
Okay.
Which would be misleading about what you're allowed to
This
use.
is what my calculator did, and I don't know, it confused me. I like graphed them both at the same time,
It should give you the same graph.
and like the blue one went all the way, but then the red one started there, so I didn't know.
Okay, now you've got me curious. That's interesting. So the calculator is taking into account. Okay, so I'm going to experiment. So Dayton said he did square root of x, quantity squared. Whoops. Delete. Don't want that exponent. Quantity squared minus 1. And if I graph, I'm going to graph just that for a moment so I can see. Interesting. So if you graph it before you simplify, I didn't expect this. I expected the calculator would simplify it and give me the whole line. So it does actually show it right. I learned something new. Because if we had simplified it, the square root of x squared we decided was x, right? Minus 1. Notice the difference now? It's going to graph the whole line. I'm kind of surprised, honestly.
Would I be able to get the domain out of that? The first one?
Sometimes. Okay, the question was, can you get his domain out of that? I can't say it would always help you and work that way.
Yeah, because I didn't know how it starts on.
Right, because in this case, yes, can we look at the graph? Does this agree? Because if we look at the domain here, okay, domain, remember we read left to right. So as I start from the left and go left, notice, where does my graph start? At what x value does my graph start? It starts at x equals 0, and domain is our x values. And then if we trace over here, my x values keep going. I learned something new. I didn't think that's what the graph would do, honestly. So, in that case, it did work. It helps. And here's my thought. I've said several times, I'm a big one, use the graph and the algebra together, right? So this is me looking at the algebra, looking at the equation, but then we just confirmed it with the graph. So, use them together, hand in hand. Okay, questions on the domain on fog? Okay, let's try golf. So G composed with f of x means we're doing G of f of x. Which, okay, oops, I need an extra parenthesis there, don't I? G of f of x, which means I'm taking what and putting it into what? I'm going to take f and put it into g. So what is f? X squared minus 1. And we're going to put it in g wherever the x is. So what does g say? G says square root of x. So that x now is going to be replaced with, what was f? X squared minus 1. So what's that going to look like? Square root of x squared minus 1. Okay. So, start thinking about this one. We have to figure out what kind of values we can put into x. Any thoughts? We have already talked this year. When you see a square root, because we've talked about square roots, we've talked about denominators, right? Those are the two big things to look out for a domain. What have we talked about with square roots? The value under a square root must be positive. Exactly what you said last problem, right? So what's under my square root? Last time it was just x, right? This time it's x squared minus 1. So we have to think through the fact that x squared minus 1 has to be greater than or equal to 0. Okay? If you think about solving this, add 1. X squared is greater than or equal to 1. Traditionally, what's your next step here? Take the square root, and if we were in an equation setting, you take the square root of x squared, it's x. What's the square root of 1 in the equation setting? Someone say it? What's the square root of 1 in general? 1. When we take a square root in an equation, we have to always include plus or minus. So now, and it doesn't make sense, though, to say x greater than 1 and x greater than negative 1. So this is where we think about it being an or statement, because it's greater than. Remember that from your absolute value days in Algebra 2? If it's kind of like doing absolute value here. It's going to be x greater than or equal to 1, since it was greater than, or, and then you remember the second one, we have to flip two things. Greater than to less than, and positive to negative. So we're going to say, or x less than or equal to negative 1. Okay. Stop and think, does this make sense? I can put numbers bigger than 1 in here. 1 squared is 1, 1 minus 1 is 0. I can put 2 squared in and get a positive, 3 squared, 4 squared. I can put all those numbers in and get positives, right? Numbers less than negative 1. Does that make sense? So if I put in negative 2 here, what happens when you square negative 2? It's a positive, right? And then minus 1, so that's okay. Basically, the numbers you can't do are the numbers between 1 and negative 1, because they would give you that negative value. Now, I saw Dayton already graphed it. If you're kind of, if you're hesitant, I don't know if I did this right. I'm not sure what to do. Does it make sense with the graph? Does my graph indicate that x could be greater than or equal to 1 or less than or equal to negative 1? Is that where my graph exists? Yeah, that's where my graph exists. And so that's us using the calculator and the algebra together. So could Dayton have just gone straight to the calculator on this one? Very possibly. Now, the key is if you do trace, does it give you, see, that's the thing. You're going to have to be able to figure out that that is a 1 and a negative 1, which here's one thing I watch. Okay, so at 0.9, my y value doesn't exist, right? If I arrow 1 to the right, at 1.06, my y value does exist. Well, what's between 0.9 and 1.06? It's probably the main number, a 1. Okay, and this is where the algebra confirms it's a 1. And so, now, if you need a visual before you go into interval notation, thank you. Here's your visual, right? We're going to go greater than or equal to 1 and less than or equal to negative 1. Because they're equal to's, we're using brackets, right? So if you need that visual, don't be afraid to sketch that graph. Okay, so domain. How does my domain read here? Less than or equal to negative 1, we're going to start at negative infinity up to where? Negative 1 with a bracket. Union, because there's a gap, right? If you're connecting two individual pieces of the graph, you use a U for union. And then where's the next one start? 1 with a bracket up to infinity. Okay. If only all domains were exactly the same, right? Keep working on domain, okay? Bad news, it's not going away, okay? I know domain, I know function composition, I know they're not our favorites because they're not, they take a little bit to see. Keep working at them, okay? Keep trying and don't just say, oh, I quit, I can't do them. So, yes?
I get the domain part and like implementation. I understand all that. It's just plugging in.
The composition. Okay, so we're going to have to keep,
The part that I don't
okay, keep working at it. So, now, I don't know, this could be rough the next part then.
get. Yeah, for sure.
So, the next part, we're decomposing. Instead of composing, we're decomposing. So, what we're going to do is the next part is they're going to give us one that's already put together. We have to take it apart. We're not doing anything fancy with domain or range here. We have to take it apart and come up with, okay, what could we make our F and our G so that we compose it goes together. Does that make sense? So let me get my screen where I need my screen to be. So notice it says, to decompose a function into two composed functions, find the inside function and replace it with x for the outside function. So, for each function, we're finding f and g, such that h of x equals f of g of x. So, they're calling these h of x. What you have to do is decide, okay, if h of g of x represents f of g of x, which one's f, or which one could be f, and what could we use for g? So what I will point out here, as we're trying to find f and g, notice g of x is my inside, right? And that means f of x is my outside. So we're trying to find an inside function that I'm plugging into an outside function. I think the easiest thing for me to ask on A, as you start looking at A, do you see something that we could call an inside function that we are plugging in to different spots in an outside function? So thoughts on an inside function here. What do you think, Natalie? That's what I would use. Now, and I will say on these, I only have one answer on A, but on B I have a couple different ways we can go. So there's not necessarily just one right answer on some of these. Okay, but this is what I've done on this one, is that the inside function, I'm going to use as x of 1. Now, what is it, f or g that represents my inside? That's g. So I'm going to call g of x, x plus 1. Now, we have to be able to write the outside function. My outside is f of x. And what you're trying to look at here, okay, basically, we're reversing it. So we're taking out x plus 1. If we take out x plus 1, instead of x plus 1, in that spot, there's just going to be a plain x. Because x plus 1 would have gone into where there was an x. So if you take out those x plus 1s and put an x in the place, what does that f of x, what's that outside equation look like? Thoughts?
X squared minus 3x plus 4.
Yes. Let me write that down. We'll talk about it. Okay. First thing said x plus 1 squared. If I take out x plus 1, what were we doing to x plus 1? We were squaring it. So now it's just n x squared. If I take out this x plus 1, what were we doing to it? Multiply it by minus 3. So what's here? Minus 3 times x. The plus 4 just carries through as a plus 4. Questions I can answer on that one. I know, and I don't, if you have a question, I'm going to try and answer it. I'm just trying to get you guys to reverse the process, so. Okay, try B and see what happens. Okay, B, same thing. I want to find an inside, so g of x. And I want to find an outside f of x. And always watch, because could they reverse it and say they want g of f of x instead of f of g of x? They could. Okay, so you have to pay attention. The way it was defined here is g of x is my inside, and f of x is my outside. I didn't leave enough room there to write outside. Okay? So, I like to think, what is something that I could pull out as a quantity, pull out and make that my inside? Thoughts on what could be an inside? Dave?
We do x cubed.
We could do x cubed. Okay? I'll be honest, it's not my preference, but we'll do it. And I'll show the other one here in a moment. Okay, we're going to go with this one. If you're sitting there thinking, that's not what I was going to do, hold your thought. You're not necessarily wrong, because as I said, I have 2 examples written down right here, guys. But this will work. Okay, so if we go with my inside is x cubed, so that means for my outside, pull that x cubed back out, and what would that x cubed have replaced? A plain old x. So square root of x plus 1. I would take that. Those are legitimate answers. As I said, it's not the one I would have picked as my first go-to, but it's not wrong. Okay? So I'll take that. Now, let's do an or. Give me another suggestion. Okay. X cubed plus 1. I see some heads like, okay, that's what you guys were thinking. As I said, not wrong. So if x cubed plus 1 is your inside, you take that whole x cubed plus 1 out, what goes in its place? An x. So what's this going to be? Square root of x.
So it's like the same thing, just put the plus 1 on 1.
It's just a matter of which way you put the plus 1. And here's like, when I put this on a quiz or a test, I have my main answers on the answer key. Like if there's 2 obvious answers to me, I'll put them both there. Now, if you try and do something different, okay, I started to use the word weird, but if you do something different from me, here's what I always do, is I try it. I'm never just going to mark it wrong and say, oh, it's different than mine. I'm going to try it. If it legitimately goes back together, then I'll give you the credit. Okay? Usually, I have all the options and I can't get yours to go back together right if it doesn't match one of mine. But I'm going to try it. Okay. Did you see one of those 2 ways? Okay. And I'm not saying there's not more out there, but this is the one that, And here's how I check. Okay. X cubed plus 1, if I put it into f, it becomes square root of x cubed plus 1. Okay. Okay, backside. Which, by the way, this next page, this handwritten page, is not part of what we're doing for notes. We might come back and talk about it someday, but it's not what we're doing for notes right now. So we just need to get through this guy right here. How am I doing on time?
14.
Okay. In the medical procedure angioplasty, a catheter is inserted into a heart vein in order to inflate a small spherical balloon. Suppose the balloon inflated at a constant rate of 44 cubic millimeters per second. Find the volume after t seconds. When the volume is v, what is the radius? And write an equation that gives the radius r as a function of time t, and what is the radius after 5 seconds? So we have like 4 different things to do here. Okay? Find the volume after t seconds. Okay, what information do they give us about volume? They tell us something about volume. Cubed, right? So the volume information they give us is 44 cubic millimeters per second, right? Because a cubic, millimeters cubed, that represents volume. So this is inflating 44 millimeters per second. So, okay, think with me. After 1 second, what is the volume? 44. 44 cubic millimeters. Okay? Basic math here, trying to lead you to something. After 2 seconds, what is the volume? 88, because 44 per second, right? So 88. Now, the question we want over here is after t seconds. So what's, after 1 second it was 44 cubic millimeters. After 2 seconds it's 88 cubic millimeters. We could talk 3 seconds if you want. We could talk 4 seconds. But how am I going to get t seconds, some unknown value? 44t, right? Because it's 44 times however many seconds. Did you see that connection? So v equals 44t. So in order to find the volume, it'll be 44 times however many seconds. Hold on to that because we'll use that later. Okay? Now, when the volume is v, what is the radius r? Okay. Volume, radius r, what shape are we talking about? They specifically told us a spherical balloon. Okay. Here's the high dollar question. What is the volume of a sphere? But I need a sphere, so I need volume. Huh? Can you have a hint? Let me see what Jacob has to say. It is. We've got to get, so pi r cubed, there's a constant in front of it. Connor? No? 4/3 pi r cubed. There you go. Okay, so let's see, where am I going to write this? So we've got to do a little bit of work with it, but that's what you need to get started. Volume is 4/3 pi r cubed. Now, if we didn't have Jacob to help us along there and you're at home, you're saying, I have no clue, should you just skip this problem solely because you don't know the volume of a sphere? No.
Get on the Gobbler to find out.
Exactly. Your phone is probably sitting right next to you, or your iPad or something. Get on there and Google volume of a sphere. Yes? That is not the reason to skip a problem like this. Okay? You guys can come up with a billion other reasons to skip it, I'm sure, but that is not a valid reason. Now, okay, so when the volume is V, what is the radius R? So what that means, when it says what is the radius R, we need to take this lovely equation here and solve it for R. Okay, we need to solve it for R. So we need to get R by itself. My suggestion to get us started is how do I move that 4/3 away from the R? We'll deal with everything else here in a moment. Well, we could go ahead and deal with pi if we wanted to, but thoughts on how to move 4/3 away, move it to the other side? Okay. Divide by 4/3, or you said multiply, and you're starting to say multiply. Multiply by the reciprocal. Okay? And it's not that you can't divide by 4/3, but you end up having to switch to reciprocal anyways. So, to move the 4/3, we're going to multiply by 3/4. What I do to one side of the equation, we do to the other. What is 3/4 times v? 3/4 v. You can also say 3v over 4. They're equivalent. So 3v over 4, 3/4 v equals pi r cubed. Okay. And as I said, we could have dealt with the pi in that same step, but I'm just trying to get us, through pieces. It's pi times r cubed. How do I move the pi? If it's pi times r cubed, divide by pi. Now, when we get to the other side, we don't want to divide a fraction by a pi, right? But, okay, we just talked. Dividing by pi is the same as multiplying by what? Yeah. Dividing by something, you can multiply by the reciprocal. So dividing by pi, which if you want is pi over 1, we're now multiplying by 1 over pi. And this is why I said, could we have done this along with the last step? We could have. So multiplying by 1 over pi. Now, what happens here with 1 over pi times pi? The pi's do what? They cancel, right? So we're left, and I'm going to flip this as I go. We're left with r cubed equals 1 over pi times 3v over 4. Put that together as one fraction, and we have this lovely value of 3v over 4 pi. No, it's going to be pretty. Sorry. Okay. We're almost there. How do I solve this for r?
You have to root both sides.
Yeah. If it was r squared, we'd say take the square root. Since it's r cubed, we're going to take the cube root. If we take the cube root of the left, we take the cube root of the right. So cube root of r cubed is just r. The cube root of 3v over 4 pi, guess what? Cube root of 3v over 4 pi. We're going to leave it as that. That's usable. Okay, and that's what we need. We need an equation that we can carry down and use here in a moment. Okay. Are you with me? C. C says to write an equation that gives the radius r as a function of time t. So when it says we want an equation r as a function of time t, means I want an equation that is r equals and has what variable in it? A t. Now, what do we already have for r equals? We have r equals the cube root of 3v over 4 pi. However, so right now, this is an equation that gives us r as a function of v, because it's r equals and it has a v in it. I don't want a v in it, though. I want a t in it. How can we rectify this? You see it, Jacob?
Put 44t in place of the v.
Put 44t in place of the v. Where's 44t coming from? Yeah, didn't we already do that? We already found v as a function of t. So we can take, okay, so this equation came from right here, right? Now we can take this equation up here and put it in place of v. So now I can rewrite this as r is the cube root of 3 times v, but v is 44t over 4 pi. All we have to do is clean that final thing up a little bit. Me personally, before I do 3 times 44, I'm going to look vertical. What do you see vertically that you can do? Is there anything we could cancel? There's a 4 down here. What do you know about 4? 4 goes into 44. This is kind of like a cross canceling, isn't it? 4 divided by 4 becomes 1. 44 divided by 4 becomes what? 11. So then I can do 3 times 11t, which is going to be 33t over pi. And this is all under a cube root. I like to do that right there because if I do 3 times 44 and get like, what, 132 or something, I'm not going to necessarily think to divide that by 4. If I divide 44 and 4, that's more obvious in my brain. Okay? So that right there is the first part of write an equation that gives the radius as a function of t. Okay, last part. What is the radius after 5 seconds? Was there a point in doing this? What is the radius after 5 seconds? What do I do? Yeah, we're putting 5 into the equation, aren't we? So we're going to do r equals the cube root of 33 times 5 over pi. Guess what? That's not a very pretty answer, is it? Okay, calculator challenge. Can you do all this on your calculator? Here's the big thing. Have you found cube root? 2 options I will give. Math menu. Math menu has almost everything you'll ever need in it somewhere. If I go into math menu, what do you notice? Number 4 is a cube root. And what's number 5? It's an x root. So you need to do 4th root, 5th root, 6th root, 7th root, 33rd root. Can you do it? Yeah. So I just need a cube root, so I'm going to do that. I'm going to go ahead and put a fraction under my cube root. 33 times 5 on top and pi on bottom. Can you do something like that? Maybe you've already done it. Your answer, however you put it in your calculator, should agree with mine. So that's the end question. Did you get the same result? Okay. So R comes out to be 3.744938504. If you're comparing your calculator answer, the radius, so I'd give a couple decimal places. So the radius is approximately, what, 3.74? And what would our radius be measured in? Millimeters. Okay, if you haven't already written down the homework, it's page 116. 2 through 8, evens. 12 through 30, evens. and 31. I will say, I know there are a couple of tricky ones in homework. Okay? I am well aware. We will talk about tricky ones tomorrow, but give it all a try. Read your directions. Okay? Do they want you to do fog and Gauss? Do they want you to do domains? Are you just doing F plus G, F minus G, F times G, F divided by G? Read your directions on each section. Okay? Other than that, bring this back. We'll talk about tomorrow. Have a good day.